Hello, welcome back. Let us continue solving physics national exam. This paper is going to be different from the previous one. For today, the first question it says fundamental physical quantities distinguished from derived physical quantities due to their weights. So at this point we need to recall the 7 fundamental physical quantities. In my previous video I tried to mention those 7 fundamental or basic physical quantities. These are amount of substance, which is mole, as you see here in the figure. The second one, it is length, which will be measured by meter. This is length. And the first one is amount of substance, and the third one is mass, which will be measured in kilogram, and time in second, temperature Kelvin, current in ampere, and luminous intensity, which is candela. These are the 7 basic physical quantities. So it says fundamental physical quantities distinguished from derived quantities due to their its A. Measured values that are combination of 2 or more. No, it's not a combination of 2 or more, just one unit, as you see. And B. Measured values that are direct and independent of other quantities. That's correct. And C. Units that are determined from combination of other quantities. No combination here. And D. Measured values that are grouped into vector quantities. Not necessarily, so the answer must be B. When you go to the next question, it says the amount of matter contains in a body is defined as. This time it is the question by itself is direct definition. Amount of matter in a body, it is mass. If you remember, there is a big difference between mass and weight, but normally what is the definition of mass? As you see here, mass is the amount of matter in something, in a body, you can say. This is a definition of mass. But weight, it is a force, a downward force. That's mg. Mass times gravity will give you the weight. But most commonly, weight and mass, students, they are considering them like same, but they are not the same. So anyways, this question is definition, so the answer will be mass. So the amount of matter contains in a body is it is mass. Okay, when we proceed to the next question, it says which one of the following factors does not affect the frictional force of an object slides along a horizontal surface? Which one is not? So there are choices: roughness or smoothness of the surface, normal force applied by the surface, contact surface area of the object, and the weight exerted on the surface, it says. If we have an object on a horizontal surface, there are 2 forces here. One is the applied force. It might be pull or push. If the object is moving to the right direction, there will be a pushing force here. It might be pulling, it doesn't matter, but there will be opposite force, which is frictional force. Normally, frictional force, the formula for frictional force, it's going to be mu times force normal. Mu means coefficient of friction. Coefficient of friction means roughness or smoothness of a surface, so that affects. And normal force means it is the same as in case of the normal force is upward, or the weight in case of horizontal. If the object lies on a horizontal surface, the normal force is the same as mg, or the weight of the object. Therefore, frictional force is the same as mu mg. Mu is a constant. That is, this constant will be determined by the roughness of the surface. The more the rough the surface, the coefficient of friction will be larger, but it's always between 0 and 1. So as you see here, the nature of the surface affects the mass of the object also it affects, or the weight of the object it affects. So generally, factors that affect friction, the first one, it depends on the nature of the surface. That means rough, or the rougher the surface, the greater the friction. So the first one, A says roughness or smoothness. That's correct. And again, it is proportional to the force pressing the surface, or in case of horizontal, the pressing force will be the weight. So that D, the weight exerted on the surface, it affects, yes. And B, normal force supplied by the surface. We already state the formula here. Frictional force means it is normal force times coefficient of friction. So it affects the normal force. But C, contact force, contact surface area of the object, it says surface area. Does it affect? No. As you see here, it says it is independent of the area of the contact. So the answer will be necessarily C. The next question, it is, which one of the following force can be grouped as contact force? In previous video, we have seen the two types of force, contact and non-contact. Particularly, I was stressing on non-contact force. Those are magnetic force, gravitational force, and electrical force. Remember those. Generally, when you see contact force, those forces, okay, the force and object, when they are in contact, we call it contact force. But non-contact, best example is gravitational force. If you throw an object, it will get back to the ground. But when the object is on the air, there is no contact between the object and the ground. But the object is moving downward because there is a force, that is attractional force, gravitational attractional force. The same manner, magnetic force and electric force and gravitational, these are non-contact force, as you see. But the contact force, there must be contact between the object and the force, or the applied force. As you see here, the person or the man is pushing a cart, so that the man hand and the cart, there is a contact between them, and the force will be applied. So which one of the following force can be grouped as contact force? A, repulsive force between magnets. No, we are talking about magnet, it's not contact. B, spring balance stretched by a weight. Yes. Charged plastic and rod attract piece of paper. No, this is electrical force. And D, a freely falling ball. Again, this is gravitational force. So the answer must be B. The next question, it says a net force of 10 Newton. Force net is given, which is 10 Newton, causes an object in a state of motion with an acceleration of 2 meters per second square. Also the acceleration given. What will be the mass? Remember the formula, force is equal to mass times acceleration. This is from Newton's second law. The force is given to you 10 Newton, and the mass is unknown, but the acceleration is 2 meters per second square. Divide both sides by 2 meters per second square. Therefore, you can cancel this, and mass remain to the other side. This side, 10 divided by 2 will be 5 kilogram remain. You know, Newton is the same as kilogram meter per second square. So meter per second square will be cancelled and kilogram remains. So the answer necessarily will be D. The next question, the energy of an object due to its motion is defined as, at this stage we categorized energy into two, that those are mechanical and kinetic. Mechanical energy is the total one. Mechanical energy is the same as the sum of potential energy plus kinetic energy. Kinetic energy, the formula is half mv square, and potential energy is the same as mgh. So m and g are constant, so what matters is the height, so the position matters. If the object is at a higher level, the height increases, means the potential energy increases. So the position matters with the object. When we are discussing about kinetic energy, we are talking about motion of the object. So potential energy is more of on position, and kinetic energy is more of on motion. Because kinetic energy half mv square means half m is constant, the mass is constant, and the half also. But the v matters. As the speed increases, the kinetic energy also increases. So v determines the speed, so kinetic is more of on motion. If the object is at rest, kinetic energy will be 0. In case of potential energy, the height matters or the position. So we can generalize. Potential energy is attributed to mass and position. Position matters. The mass is, always it's constant. For constant mass we are talking, and kinetic energy is associated with mass and speed. So the energy of an object due to its motion is defined as, this kinetic energy. Okay, the next question again. A water pump has a power of 4 kilowatt. The power is given to you for kilowatt. Kilo means, multiply by 1000. Kilowatt is the same as 4000 watts given. If you want to draw 12,000 liters of water, that means the volume is given to you. The volume of the water is 12,000 liters. But 1 liter is the same as, in case of water, 1 liter is the same as 1 kilogram. So the mass of the water is given to you here, 12,000 kilogram. 12,000 liter is the same as 12,000 kilogram, because 1 liter and 1 kilogram are the same. And the height also given. The height, it says 12,000 liters of water from a depth of 3 meters. Okay, the depth of the well is given to you 3 meters. That is the height. Then what is the time required? We need the time. Okay, this is, first of all, try to record the formula. Power is equal to work over time. This is it. But this time the work then will be due to the height, it's going to be mgh over t. We have everything here. Let's go to the next page and solve it. So it's going to be power is equal to mgh over t. From this, let us try to solve for t. If you multiply crisscross, p times t will be pt is equal to 1 times mgh will be mgh. Then divide both sides by p, because our objective is to get the time. Then this will cut out and the time will be mgh over p. Okay, therefore the time will be, the mass we have got it already, 12,000 multiply, it has ignored the time, the unit for the time being. The gravitational acceleration, it says use 10. As you see here, gravitational acceleration, you can use 10, it says. Okay, therefore, and in place of height we can use 3 meter already given, divide by, and the power is 4,000 already, we got it. Therefore we can cut 3 zeros here by 3 zeros, and again by 4 1 is by 4 3, then 3 times 3 will be 9 times 10 90. The time will be 90 what second, because the unit of time is second. But when you get back and see the choice, there is no time written in second. It's all in unit. I mean in minutes. So we need to change this time into minutes. So to change from second to minute, we need to divide by 60. From second to minute, divide by 60. If it is minute to change into second, multiply by 60. Therefore, this time it is second, so we need to change into minute. So divide by 60, cut the 0, and simplify. By 3, 2, this by 3 will be 3. 3 over 2 means it is the same as 1.5. 1.5 minutes. That's going to be the time that we need to extract or to take out the water. So the answer will be B. The next question, a bus is moving along dotted line path as shown in the figure below. So here is the bus. As you see, the position of the bus is here. Position A, B, C, and D are visible here on the figure. Which one of the following is correct about the nature of its velocity and acceleration along the path? So as you see, there is a kind of hill. The bus is moving, so it has to increase its speed. When the speed increases, means the acceleration increases. So it says A, its velocity is constant throughout the path. No, velocity cannot be constant. If the velocity constant, the bus cannot move up. It has to increase the speed. B, from A to B, its velocity and acceleration are non-zero and constant. It says velocity and acceleration at the same time cannot be zero. I mean, velocity and acceleration at the same time cannot be non-zero and constant. If velocity constant, acceleration will be zero. Don't forget that, because acceleration means change in velocity over change in time. So the change in velocity constant means v final. For example, if it is 10 meter per second square, v initial also 10 meter per second square. That's constant, means this one. So if you take the difference, or if you try to find the change in velocity, it's going to be zero. 0 over time will be 0. So velocity and acceleration cannot be constant at the same time. Non-zero constant can't, because if the velocity constant, the acceleration will be 0. C, from B to C, velocity is constant, but its acceleration is 0. From B to C, it has to increase its speed, as I said before. It has to increase its speed, and then the velocity varies here, because it's moving up on hill. D, from B to C, velocity is variable and its acceleration non-zero. Yeah, this one is appropriate. When we are talking about from B to C, either the bus should increase the velocity and the acceleration will be constant, or the velocity might decrease, but anyways there will be variable velocity and there will be acceleration also. The acceleration will be non-zero, because velocity change means acceleration is there. So the answer necessarily will be D. Next one, it says which one of the following motion does not pair with their corresponding type of motion? A, wheel of a car, it's rotary, yes. B, moon around Earth, it must be rotary again, because the moon will be revolving around Earth. But it says rectilinear. Rectilinear means a straight line motion, so this one doesn't work. Which one is not? B. C, simple pendulum, it is vibratory, or like a kind of harmonic motion. So simple pendulum will be simple harmonic motion, and car around circular path, it is curvilinear motion. Yeah, this is also true. So the answer will be B. The next question, two pulley systems as shown in the figure below, considered as an idea. Which one is the correct conclusion about the velocity ratio in the above? The first one is fixed and the second one is movable pulleys. We do have two. This one fixed and this one is movable. In case of fixed, effort and load must be the same. If 100 Newton load is there, we need to apply 100 Newton force, and the direction of the effort and the load are different. But in case of movable, there are two tension force here, up and down. So if the load is like 200 Newton, necessarily the tension will be this load force will be divided into two, for effort and for the fixed position here. Two tensions are the same, so it will be 100 Newton will be here and 100 Newton will be here. It will be divided, so the load will be the larger and the effort and the other tension will be, they will be half of it. So A, movable pulley, it is 200 Newton load raised by 100 Newton effort. That's going to be correct even when you discuss about the load and the effort. But look, B, fixed pulley, 200 Newton load, it must be 200 Newton effort, because the load and the effort must be the same. That's wrong. C, movable pulley, 200 Newton load raised by 100 Newton effort. The velocity ratio, we'll discuss about that, A and C. And again the same like for D. But try to remember, in case of fixed pulley, the load and the effort are the same, so the mechanical advantage will be 1, and the distance moved by the load and the distance moved by the effort will be the same, so the velocity ratio will be 1 in case of fixed one. But when you come to movable one, the distance that the effort moves will be 2 times the load, so that the velocity ratio will be 2. Okay, that is the main difference. In case of ideal pulleys, velocity ratio in case of movable it is 2, velocity ratio in case of fixed pulley will be 1 or 100%. Therefore, look B, it is fixed pulley, fixed pulley, 200 Newton load raised by 400, wrong. But A, movable pulley, 200 Newton raised, we agree with this, but the velocity ratio, it must be 2. That's correct, because we are talking about movable one. When you come to fixed one, the velocity ratio, it was supposed to be 1, but it says 2, which is wrong. The next question, the action of force having turning effect on an object is given at a given or about a given axis of rotation is termed as. This is also a definition. You can consider the door in your classroom or wherever. It will be fixed at some point. So when you want to open, you are going to apply force at this point. So the door, when you apply a force, this door will move forward and backward about the fixed position. This movement, okay, because of the force, there is a movement, okay, rotation, or there is a rotation. That's said to be torque. So the definition of torque is the action of force having a turning effect. Okay, the action of a force having a turning effect about the fixed axis, we call it torque. So the answer will be C. It's just direct definition. The next question, the average kinetic energy of a particle is indirectly determined by for example, in a room or in a box, air molecules are here and there. So when the temperature increases, the movement of the molecule increases. Or like considering like you are boiling your water. So at the first, the water molecules were as a constant motion, but when you increase the temperature, the movement of the molecule increases. So the temperature affects the movement of the particles. That means the kinetic energy of the particles in a molecule, in an object. So the average kinetic energy of a particle indirectly determined by temperature, not by mass or pressure, volume. These are other issues. So kinetic energy of particles in a body will be determined by the temperature. As temperature increases, the movement of the molecule increases, but the temperature decrease means it will be less movement. The next question, what is the reading at negative 40 degrees Celsius? Again, at this point, every one of you try to remember negative 40 degree Fahrenheit is the same as negative 40 degrees Celsius. Okay, Fahrenheit and Celsius will be same at negative 40. Remember the reading. Therefore, at negative 40 degrees Celsius. We are asked in Kelvin actually. So to find the Kelvin, what to do? The Celsius plus 273 you have to do it. Always it is a formula to find the Kelvin. So we have the Celsius which is negative 40, so that I'm going to add negative 40 plus 273. That means since one negative one positive means I'm going to subtract 273 minus 40. When you make it will be 233 Kelvin. So the answer should be it's A. Okay, the next question, the speed of sound in liquid is speed of sound depending on the medium that it's moving, it varies. There are three mediums normally that we know them. That is liquid, solid, and gas. In gas, the particles are somehow far apart, so the speed of sound will be less. But in liquid, the molecules are, they're compact, they're sticking each other, so the speed of sound will be faster. We can say the fastest one here. But when you come to liquid, it's better than the gas. The molecules still near each other than the gas, so that the speed of sound is faster than the gas and slower than the liquid. So different liquid, they do have different speed of sound, but generally we can say sound travels slowest in gases and faster in liquid and fastest in solid. So this is a comparison in general. So A, the speed of sound in liquid is equal to speed of solid. Speed of sound in solid, no, it is greater than its speed in gas. That's correct. In liquid it's greater than in gas. C, it's greater than its speed in solid. Wrong again. It's less than its speed in gas. Again it's wrong, so the answer should be B. So these are some of questions prepared from the past paper. I'm going to continue with additional videos. Don't forget to subscribe, like, and comment. Thank you for watching.